Now we're gonna find the Laplace. We're gonna find the Laplace transform of the sine function, the sine t. Okay, we will use the same technique. We will apply the definition. So the Laplace transform of sine t is gonna be the integral between 0 and infinity of the sine t times e to minus st dt. Here we can use the definition of the improper integral. So f of s is gonna be the limit as x goes to infinity of the integral between 0 and x of s the sine of t e to minus st dt. Okay, so we first focus on this integral here. We see that to find this one we have to do integration by part. We will do it twice because the first one we get the cosine, and after that we get back to sine, and we're gonna see what we can get from there. Okay, so the technique is that we will differentiate the sine and integrate the exponential. Okay, here differentiate, integrate. We'll differentiate the sine, we get cosine of t and minus sine t. And here we have e to minus st. When we integrate, we get minus 1 over s e to minus st, and doing it one more time, we get 1 over s squared e to minus st. Okay, we have a plus minus plus. Okay, and using this tilted multiplication, if we want to stop here and integrate, we multiply directly. Okay, so we get in this case minus, so this is this value here, this integration here, so it's gonna be this first term will get minus 1 over s e to minus st sine t minus cosine t over s squared e to minus st minus, because we want to stop here, this is between 0 and x, we want to stop here, we integrate again between 0 and x, the value of sine, let's take the 1 over s squared outside, we'll get sine t e to minus st. Okay, so because we need to go back here, and once we take the limit, okay, we get f of s. This limit here, the sine t e to minus st, it's always gonna be a value that we have to determine. Okay, but once we do that by taking x to infinity, we see that the exponential of the sine minus s x always win. The same thing for the powers. Okay, let's see clearly what we mean here. So let's evaluate this one. This is the limit as x goes to infinity. So I'm gonna take this one to the front, this one here. So this one is gonna be minus 1 over s squared, the integral between 0 and x, sine t dt, e to minus st, minus the limit of 1, let's take 1 over s here, e to minus xs, sine x. Okay, so I'm evaluating this one here, and when I plug 0 here, I get 0, and I move to the next one. So here I have 1 minus cosine x e to minus sx over s squared, And once I do evaluate at 0, I get minus 1 over s squared, because the cosine of 0 is 1 and this one at 0 is 1. So here, the limit now for this part here, this is 0, this is 0, okay? Because the exponential e to minus sx wins over the cosine and the sine, and therefore this limit here is 0. And all I'm left with is this one here. So here I have f of s, so it's minus 1 over s squared. The integral, let's try to get to the definition. The integral between 0 and infinity of sine t e to minus st minus 1 over s squared. Here I need to have a plus here because it's 0. When I evaluate, it's 1 plus 1 over s squared. Sorry, it's 1 over s plus 1 over s squared, because when I do evaluate at 0 with this minus, I get plus. So here, what's this one here? This is the one that I'm looking for. This is my Laplace transform. Yes, this is my Laplace transform here. This one here. Therefore, I have f of s plus 1 over s squared. F of s is 1 over s squared. Okay, so now using some algebra, okay, I have s squared plus 1 f of s, okay, over s squared is 1 over s squared. And therefore, I have my f of s is just 1 over s squared. 1 over 1 plus s squared. This is the Laplace transform of the sine. Okay, note here. So the key here is to showing that this integral is 0 except when x is 0, I get 1 over s squared. And once I get here, I take the limit. But I remember that this is just the definition of the Laplace transform of the sine. I take it to the left and I get s squared plus 1 over s squared. And that one is equal to 1 over s squared. And once I do the algebra, I get s squared plus 1 f of s over s squared is 1 over s squared. And I simplify, I get f of s is 1 over 1 plus s squared. And this is the Laplace transform of sine t. It's 1 over 1 plus s squared. Okay. Thank you very much.